Hey everybody, this video is for 9.1 and 9.2a review. So what we started with was 9.1. We looked at what does A do and what does C do to the graph. So how do you know by looking at a quadratic whether the parabola will open up or open down? That is looking at the A term, okay? You look at the A term, okay? If it's positive, that means it opens up. If it's negative, then it opens down. So that's one thing that the A term controls. The other thing the A term controls is if it gets narrower or wider, and that has to do with if it's bigger than 1 or between 0 and 1. All right, so looking at this next example, all right, I would look at this -3 and know that that's the A term. Okay, the A term controls if it opens up or down. This time it's negative, so we're going to open down. Okay, the other thing that A is controlling is if it's wider, narrower, or the same. So we look at this number here. It doesn't matter if it's positive or negative, but if it is bigger than 1, that's going to make the graph increase faster, and it's going to make the parabola look narrower. The sides are going to get skinnier, closer together. Then we have this thing called the B term. Okay, the C term. B term is coming up. This is the C term. +4 is the C term. That controls if it moves up or down. So since it's a +4, it's going to move the whole graph up 4 units. So the vertex and everything else is going to move up 4 units. Okay, looking at the same thing again. Okay, does it open up or down? So again, here's our A term, +1/2. Since it's positive, we're opening up. Okay, since 1/2 is a number between 0 and 1, we know that it's going to get wider, and we know that the -5 is going to be our C term. That's going to move the whole graph down 5 units. Okay, and then when we graphed these ones, what we looked at, okay, was having that axis of symmetry be 0. Okay, when we learned this, we didn't know what an axis of symmetry was yet. But what we said was let's put 0 in the middle of the graph. Then we can plug in 1. Our answer to 1 will give us the same as -1. Our answer to 2 will give us the same as -2. So we want to get those x's and see what y's come out. Okay, so then we know that this graph should open up because it's the first term is positive. We know that the whole graph is going to be shifted up 2 units. So if we plug in 0, that's 0 squared plus 2, which is 2. Okay, so if you plug in 0, you get out 2, so that's our vertex. We're going to go up from there because this one is a smiley face. We're going to be opening up. If you plug in 1, that's 1 squared plus 2, which is 1 plus 2, which is 3. That's also going to be the answer if you plug in -1. So at 1, I'm going to be at 3. At -1, I'm going to be at 3. And then we'll do one more. If you plug in 2 squared plus 2, that's 4 plus 2, which is 6, which is also what we would have gotten if we plugged in -2. So at 2, we're up to 6. And at -2, we're at 6. As soon as you have 5 dots, you're ready to connect the dots. Okay, this is called a parabola. Okay, the domain, okay, is always the same answer this chapter. It's all real numbers. There's a symbol for it. It's like an R with another stem. Range has to do with which y values are possible. If it's a problem that is opening up or a smiley face, we use the greater than symbol because what we have is a minimum. We have a number that y reaches that's the smallest possible number y ever is, and that's this point right here. Y never gets below that horizontal line. That has a value of 2. So we know that all the y values are either 2 or bigger. And that's how that first one works. Okay, comparing that to graphing the tougher ones. Oh, my fault. Let me go back. So looking at graphing a trinomial, okay, comparing that to what we have been looking at. So we'll just do this once. When there's a B term, now we have to look for the equation for the axis of symmetry, which is right here. So actually, these two should be reversed. I'm not going to be able to get the axis of, or the vertex without the axis of symmetry. So those should have been backwards. So that's just a typo. But what we have for axis of symmetry is this equation, negative b over 2a. And what we're plugging into those are these values. A is 2, b is negative 4, and c is negative 1. That's going to help us with something a little later. So for negative b over 2a, so it's really the opposite of b over 2a. Since b is already a negative 4, that's going to turn into a positive 4 in our next step, over 2 times 2, and that is going to be 4 on the bottom too. So what we end up with there is positive 4 over 4, which is 1. So our axis of symmetry is x equals 1. What that is a vertical line that cuts the parabola right in half. And that's the graph right there. This is the line x equals 1. Okay. What we do with that is then we look for the vertex. Okay. And what we do is we plug 1 in to the equation. Oops, I'm sorry. Let me do it this way. So the vertex is going to be whatever we just got, which is 1, comma, whatever we get when we plug 1 in. So that's what we're going to do next. We're going to plug in y equals 2 times 1 squared minus 4 times 1 minus 1. Okay, when we do that, we have to do the 1 squared first. That's the first thing in our PEMDAS order of operations. 1 squared is 1 times 2 is 2. Negative 4 times positive 1 is negative 4, and then we have another negative 1. So if you subtract 2 minus 4, you get negative 2. Minus 1 more is negative 3. So that's the y value of the vertex. So the vertex is at 1, negative 3. So on that blue dashed line, I'm going to go 3 down and put a dot. That's my vertex. From there, I know the graph is going to open up and be a little bit skinny since we have a positive a term. Okay, this is, and then like I said, it's going to come back in a second here. Okay, this is where the y-intercept is a nice one to plug in. If you plug in 0 to any quadratic equation, you're going to get out whatever the c term is. So for this one, that's 0, comma, negative 1. So I know that I have a dot that I can place at 0, negative 1, which is right here. What I can do, since that's just one dot away, one spot away from that red line, I can go one spot away again and put another dot. So these are going to be my 2. I don't know how I keep messing up my marker. There we go. There's really 2 dots that would be at negative 1, 0, negative 1, and 2, negative 1. Okay, then I need one more point. I need an other point, and that can be anything. What I have here is a dot at 0, and a dot at 1, and a dot at 2. So I just want to get one more. So I want to get something that's close to that. So what I would maybe try for this one is to plug in 3. And then what I'll put for the y value is whatever we get out when we plug in 3. So since I already have a 0 and a 1 and a 2, I'm just picking the next smallest number. So y equals, our equation is 2 times 3 squared minus 4 times 3 minus 1. We have to do exponents first. So we would do the 3 squared, and that's 9 times 2 is 18. Minus 12 minus 1. So that's 6 minus 1, so 5. So if I plug in 3, I get 5. So I'm going to put a dot at 3, comma 1, 2, 3, 4, 5. That's 2 steps away from the line, so 2 more steps away, I'm going to have another 5. And then now I have my 5th dot, so I can go and make my parabola from here. It opens up, it's a little bit skinny. So narrows because of that positive a term that's bigger than 1. Domain is what x values are permissible, what x's we can plug into the equation. For every parabola we graph, it's going to be all real numbers. Okay, range y is greater than or equal to Okay, what we're going to look for that is the lowest that y ever gets, and what that's going to be is the y coordinate of the vertex, which is -3 this time. So there's two examples of graphs. All right, there's a worksheet that can go with it. Today's just more practice on the stuff we've learned this week. So thanks for watching.